So this is going to be a little bit of a long video. I imagine it's going to take us more than one video to get through this. So again, take your time on this. Section 6 is solving exponential and logarithmic equations. The good thing is we've done a little bit of this, so hopefully we can go through this a little bit quicker than normal on certain parts of it. Let's start with just a couple of quick definitions. These are pretty straightforward. The first one is exponential equations. Are equations in which variable expressions occur as exponents. The second one is logarithmic equations. Are equations that involve logarithms of variable expressions. And the last one is something you're familiar with, extraneous solutions. And that's actually an extraneous solution, is an apparent solution that must be rejected because it does not satisfy the original equation. So basically what we're going to be doing is we're going to be solving some equations here, and it's going to either be dealing with exponential equations or logarithmic. So I'm going to take you through this first example. So it says properties of equality for exponential equations. This is very straightforward, and we've talked about this. It says if b is a positive number other than 1, and you see this. So it says b to the x equals b to the y. Well, that's only true if x and y are the same. Otherwise, that can't be equal to each other. So if and only if x equals y. So therefore, if 5 to the x equals 5 to the 4, then x has to be equal to 4. And then conversely, if x is equal to 4, then 5 to the x will equal 5 to the 4th. Okay, so let's go through this. Basically, what we're going to be doing is this. We need our bases to be the same. So that way, if our bases are the same, then all we have to do is set our exponents equal to each other, and we can solve. So in this problem right here, we have 64 and 16. What we're looking for is a common base that we can create out of those. And this is going to be the most difficult part for you guys because you've really struggled with breaking down numbers into a series of exponents. Like, for example, you could technically write 64 as 8 squared because 8 squared is equal to 64. You could write 16 as 4 squared. But we need these two to be the same. So the only base that I can get out, what I do is I always look for my lower number and I say what is the most common base, or what is maybe the only base I can get out of that. And the only base that I can get out of 16 is 4. And what it is that means we have to rewrite it as 4 squared. Now, that means that 64 is going to also have to be written as a base of 4, and it can be 4 to the third power. So now our bases are the same. So we're rewriting each power with a base of 4. So we have 4 to the third power, 4 to the second power, and now we expand. You'll do 3 times x, so you'll have 4 to the 3x, and you'll have 4, and then we have to multiply 2 times x and 2 times 1, so that will be 2x plus 2. Remember, the reason why we're multiplying these is because it's a power to a power. You always multiply power to a power. 3, the exponent out on the inside multiplied by the exponent on the outside, exponent on the inside multiplied by the exponent on the outside. So now we're going to use our power of a power property. Because both of our bases are 4, we simply have to solve an equation 3x equals 2x plus 2. Minus 2x to both sides, and you get x equals 2. So the solution here is 2. If we plug that back in, we have 64 to the second power equals possibly 16 to the 2 plus 1 power, which is going to be, Yep, that's right. 2 plus 1 power. So we have 16 to the third power equals 64 to the second, and you do indeed get the same answer, 4,096. Okay? So again, the idea of this is you're trying to get your bases to be the same. So I know that up here I have this one to do on your own, But I want to go through this one with you because I know you're going to get really confused on it anyway, because I know we struggle with negative exponents. So let's just go through this one, and then I'll have you do this one on your own. So here, we have 3 to the x equals 1/9 to the x plus 3. Again, I'm looking at 3 as my base. There is no other way that we can break down 3, so 3 is going to have to stay as our base. So it's going to have to be 3 to the x equals, and we're going to have to somehow change 1/9 to a base of 3. And again, I know you guys struggle with this, but think of it this way. You know that 3 squared equals 9, but because it's a fraction, just make it negative 2. Because you said 3 squared, if 3 squared is 9, then that means 3 to the negative 2 will be 1/9, because a negative power creates fractions. So this will end up being 3 to the negative 2 to the x plus 3. So again, when we rewrite this, it'll be 3 to the x equals 3 to the negative 2x minus 6. What I did was I took negative 2 and multiplied it by both of these. I distributed. So now, because we have a base of 3 on both of these, it'll be x equals negative 2x minus 6. So now we add 2x to both sides. We get 3x equals negative 6. Divide both sides by 3, and we get x equals negative 2. And again, I won't do this to save time, but you can plug this back in here to check to make sure that it's a solution and that it checks out. Usually whenever you get only one solution, the solution's going to work. The only time you're going to have extraneous solutions is when you sometimes get 2 solutions and one of them sometimes won't work. Okay, so again, I'm going to pause the video in a few seconds here and go ahead and hit play when you are ready to see the solution here. Okay, so basically you should have gotten x equals negative 8/5. Real quickly, let me go through this. The common base between 100 and 1,000 is 10. 100 is 10 squared, 1,000 is 10 to the third. Distributing through our powers, we get 14x plus 2, 9x minus 6. Then we set those two equations equal to each other, minus 9x to the left, minus 2 to the right, 5x equals negative 8. Divided by 5 on both sides, we get x equals negative 8/5. Okay, so let's move on. Again, if you have questions on that later, that's fine. Just note that. Okay, so the next thing, it says, oftentimes we cannot rewrite an exponential equation using the same base easily. When this happens, we can solve the equation by taking the log of both sides. We've done this already, so hopefully this is not too difficult. We have 6 to the x equals 27. And obviously, the only way to solve for x is to get that out of the exponent. And the only way to get rid of it out of the exponent is by taking the logarithm of both sides. And what we said is to get rid of a log, or to get rid of an exponent like that, we will take the logarithm, and the base will have to be the same as the base over here. So it's going to be log base 6 of 6 to the x. Now, whatever you do to the left side, you got to do the right side. So it's going to be log base 27. Oh, sorry. Little typo there. Log base 6 of 27. Now, the log base 6 and 6 cancel out. That was the point. We've done that earlier. It just equals x. Those are inverses of each other. So basically, x is equal to the log base 6 of 27. And what you can do is you can use a calculator to put it in as a change of base. So it would be, in your calculator, you would write log of 27 over log of 6, and you should get approximately 1.839. And again, you can check this in the original equation to make sure that it works. Okay, again, I'm going to hit pause, try this one on your own, and hit play when you're ready. Okay, so hopefully you got an answer of x is approximately 1.618. Again, because it's base 9, we take log base 9 of both sides. Okay, so we have log base 9 of 9 to the x equals log base 9 of 35. The log base 9 and 9 cancel out, and then to do log base 9 of 35, you do log of 35 divided by the log of 9 and you should have gotten 1.618. Okay, so let's move on to another example. This is a little bit more difficult, so I'm going to do one that's a little bit more difficult, and then you'll do the second one on your own. So in this one right here, it's not really different, okay? The idea is we're still going to end up having to use logarithms to solve. But what you need to remember is that we don't want to use logarithms until that's the only thing left to do. So we need to get rid of this -7 first, and we need to get rid of this 4 first. So the first thing we do is we add 7 to both sides to get 4e to the negative 0.3x equals 20. And then we divide by 4 to get e to the negative 0.3x equals 5. Now we can use logarithms to start solving this. And remember, e is a base. Okay, e is the base of natural log. So what we're going to do is we're going to take the natural log of both sides. So we have natural log of e to the negative 0.3x equals the natural log of 5. Again, the natural log and e cancel out. So we are left with negative 0.3x equals the natural log of 5. So all we have to do is divide both sides by negative 0.3. So we have x equals the natural log of 5 divided by negative 0.3, and you can put that right into a calculator, and you get x equals negative 5.365. And again, it's not any more difficult. You just have to make sure that you get your exponential form all by itself before we start taking logarithms of both sides. Okay, again, try this one on your own. Hit play when you're ready. Okay, so in this case right here, you should have gotten x is approximately 0.155. You take the log base 7 of both sides. So you ended up with the log base 7 and 7 cancel out. You're left with 9x equals log base 7 of 15. Divide by 9 on both sides. So here you would put log base 7 of 15 in your calculator by doing log of 15 divided by the log of 7, and then you divide by 9 at the end to get 0.155. Okay, so moving on to logarithms. Properties are the same way. If I have log base b of two different things, that only works if, in this case, x is equal to y. Those have to be the same. So therefore, if you have log base 3 of x equals log base 3 of 8, then x has to be equal to 8. And also conversely, if x is equal to 8, then those two are equal to each other. So let's go through and solve. These ones are a little bit easier because there's not really a common base that you need to find. You're really just, taking the log of and setting them equal to each other. So these are a little bit easier. So we have 6x minus 16 equals x minus 1. And then we just go through and solve this. So you're going to subtract x from both sides. So you're left with 5x minus 16 equals negative 1. Then you're going to add 16 to both sides, and you're going to be left with 5x equals 15. And then you're going to divide each side by 5, just regular equations, and we get x equals 3. So our solution here is 3. Okay, so that's a pretty quick example. So why don't you go ahead and do this one on your own and hit play when you're ready. Okay, so hopefully you got x equals 5 as your answer. We have 2x plus 8 is equal to 6x minus 12 because both of the logs were the same. And then going through and solving that, I did minus 6x on both sides to get negative 4x. I minus 8 on both sides to get negative 20. And then divided by negative 4 to get positive 5. Okay, so moving on is going to be the next video. I see that we're running out of time here. So let me just end it here. And then the next video, we'll cover the rest of it. Should only be about 5 minutes.